Hey guys, and in today's project, I built an AI parking lot system. It has a gate, an LCD screen showing how many cars are parked, and, most importantly, a car detector and counter. And this is all done in real time, and it works great. And in this video, I'll show you how I built it. So this project is an upgrade from my previous parking lot system, which featured an Arduino and several infrared sensors. But this time, we're actually taking it to the next level. So just like with Passive Patrol, we'll actually be using object detection and MQTT, where the client with the camera will communicate with the gate, and you'll see more of that in a minute. So without any further ado, let's get into it. So starting off with the hardware I used the Raspberry Pi 5 as my edge node, and the Raspberry Pi 5 is a cheap and decent candidate for running object detection, and is also great for MQTT communication. And this is accompanied by a Freenove Pi Camera, which is used for detecting how many cars are in our parking lot in real time. Now this is totally optional, but I also bought a Freenove 7-inch touchscreen monitor to view our program. And moving on to the gate, I used the ESP32 dev board featuring the CP2102 serial chip, and the ESP32 is perfect for the job as it supports both Bluetooth and Wi-Fi, and it's a big step over our Arduino Mega 2560 in terms of performance, and that way, the gate can wirelessly communicate with the Raspberry Pi efficiently. For detecting if a car is entering or exiting the parking lot, I used two infrared sensors. And of course, for the gate itself, I used an SG90 Servo, which I used in the previous version of my project. And lastly, to tell how many cars are parked, I used a 16:2 LCD display, and this time with an I2C adapter. So one thing to keep in mind is that there are actually different versions of the ESP32, so if you want to copy my project, then you'll have to get one with a 5-volt source in order to power those components safely. So I'll put a link in the description on the ESP32 I used. And here's a diagram showing the whole circuit for the gate, and this varies by what ESP32 you use, but as you can see, all the components are connected to the ESP32's 5-volt source, and a ground source of course. So for the LCD, the SCL pin is connected to D22, while the SDA pin is connected to D21. As for the two IR sensors, I have one hooked up to pin D4, and the other one hooked up to pin TX2, and my servo is connected to pin RX2. And as for the software side of things, just like in my Passive Patrol project, I used YOLO 11 from Ultralytics for object detection because of its speed and accuracy, and I also used Peiho for the MQTT as it is lightweight and allows for real-time updates and decoupling. And just like in the previous version, making the board was pretty easy. All I used was a poster board and a white marker to create the 6 slots. So, how did I train the AI, you may ask? Because I'm still a beginner when it comes to training object detection models, what I did is actually follow Edje Tutorial's tutorial as a guide, and his video is an excellent guide for beginners, so I'll put a link in the description so you guys can follow what he did step by step. Basically, I used Label Studio to upload my photos of cars and created boxes around the cars in each photo. And when we got to the part using his model training template on Google Colab, I used YOLO 11S as it offered a great sweet spot between performance and accuracy. But as you can see, I only trained my model with 50 images, and a big mistake I made was using duplicate photos in cars, so my training model is not the best at the moment, but in the future, I plan on improving my model by increasing the dataset. Still, my object detection model is able to detect cars on the parking lot, and the Raspberry Pi is able to count how many there are. So then, I used his script to test my model, and it worked decently well. However, I made some modifications to incorporate MQTT communication, as you can see right here. And moving on to the MQTT, I used the Raspberry Pi as the publisher and the ESP32 as the subscriber. And how this works is that whenever the camera detects an object, which is a car, the Raspberry Pi will then publish the message that a car is on the parking lot to the local broker. And then the ESP32, which is subscribed to the topic of the message, will then receive these messages and then update the LCD on the parking lot. I also could have made another topic to influence the servo, but I didn't feel like it was necessary, but it is something I could look into in the future. So moving on to my code, on the ESP32 side, I'll go over this briefly, but again, if you want to see my full code, my GitHub repo is in the description below. So here, I included the important libraries I need and created prototypes for the functions I needed later. Here, I defined the pins for each component, such as the infrared sensors, servo, LCD, And again, use global variables for timing. I did the same with the Wi-Fi and MQTT section, where I configured my Wi-Fi credentials and MQTT broker information, such as the broker, port, and topics. So inside the setup function, it tests both the Wi-Fi and MQTT connections and initializes all the components and sensors. Then, in the loop function, which runs continuously, it reads the IR sensors and determines whether the servo should open or close. So if one or both of the IR sensors detect a car, the gate opens, but otherwise it stays closed. So it then continuously checks for new MQTT messages. And that leads us to our MQTT function. So the most important code is that it subscribes to the topic of our parking spots, so it will be able to receive messages from the Raspberry Pi whenever there's an update. And when the ESP32 loses connection to the broker, this function reconnects it back to the broker. And for the fun part, we have the callback function, and this is where we'll get messages from our Raspberry Pi, which are about how many cars are in the parking lot in numbers. And as it is received as a string, it is then converted into an integer and then updates the LCD to show how many cars are parked there. So now that we've gone over the system overview, here is a demo showing what my system does in action. So I'll see you then. So here is our parking lot. So there's our ESP32 with the two IR sensors, as well as our LCD and gate. So what we're gonna do now is that here is our Raspberry Pi with the display attached to it. And always make sure to elevate your camera, so that way the camera will be able to see all the cars and the parking slots. Also make sure that it is bright here, that the light reflects on the whole parking lot. If you guys recall from Edge Tutorial's video, he showed you guys how to run the script that he made. So yeah, like here is our model, like YOLO detect Pi. Although I converted it to an NCNN model just to make it run faster on the Raspberry Pi 5. We also have like our camera. Our threshold is 0.35 and our resolution is 640 by 480 because this is perfect for the size of this display. So yeah, let's just run it and see how it goes. Sweet. So as you can see, like with our two cars parked right there, like it's able to detect the two cars parked right there. So this is what happens when like the car enters, as you can see. And as soon as the car parks, it will show up right away on screen right here. So now let's do another car. And it will not only show up on screen, but it will also show up on the LCD display right there. So as you can see, it shows 4 out of 6 cars parked. Now, if a car wants to leave, then they have the option to do so. So yeah, like what's a parking lot without being able to leave, you know? That should be illegal. So the infrared sensor will detect the car that it's leaving, and then like the gate will close. And same thing happens with the other cars as well. All right, so as you can see, I'm pretty pleased with how our results turned out. So again, I'll be making some improvements in the future, but for now, this is what we have currently, and works pretty great. So you just have to make sure that your room is bright and your camera is positioned properly. Although I will be working on my machine learning model in the future, so yeah, stay tuned for that. But for now, this is what we have. Overall, I'm very pleased with this new version of my parking lot system. Now, it's not perfect, as I still have to work on my machine learning model, but I've had lots of fun working on this project, and it demonstrates the combination of computer vision, embedded systems, and IoT into one working system. Now, of course, this is just a small-scale prototype with Hot Wheels cars, but the same idea could be applied for even larger parking lots if you want to do so. But anyways, that does it for this video. What are your thoughts on this project? Let me know in the comment section below, and feel free to visit my GitHub repo, and all the videos that I've included are going to be in the description below. And leave a like if you like this video, leave a dislike if you don't like it, and subscribe to my channel if you haven't done so already, and until next time, I'll see you then!